Good afternoon, everyone. My name is Anvi Mishra, and I'm pursuing Masters in Economics and Bachelor's in Electrical and Electronics Engineering from BITS Pilani, Hyderabad campus. And today I'm going to be presenting my project report, which centers around quantifying the biofouling risks for the upcoming Vadhvan port. Now, Vadhvan Port is a massive greenfield project which is at its full capacity has 298 million tons per annum capacity, and this is a huge economic asset for local and global trade networks. And now, Vadhvan aims to be a ESG focused green hub. So this requires proactive environmental and operational risk management. Now, biofouling for this port acts like a hidden tax that undermines the port turnaround times and the vessel efficiency. It also adds hydrodynamic drag that everyone was talking about before me, and it severely impacts the efficiency of the 24,000 TEU container vessels. And apart from that, it also poses a infrastructural risks as the dislodged biological matter can threaten the static port infrastructure. Now, what I have done to understand this complicated mechanism around this port is I have developed asset liability matrix that takes 20 factors spanning across economic, environmental, and social pillars. Now, what this matrix does is kind of make these biological impacts into tangible assets for a better understanding of how biofouling actually affects the port. And the this framework is based on hydrodynamic modeling, and this is just one of the equations that I had used, and and what it basically tells us is the added friction coefficient due to biofouling. Now, the methodological approach that I followed is first I have calibrated all the data according to a 24,000 TEU container vessel, which has a 24,000 square meter wetted area, which operates as 22 knots within the local coastal salinity. And second is scenario modeling. Now, before me, also a lot of people have talked, but these are just the basic numbers. At the very early stages, there's just the 18.6% friction jump, but eventually it can become a 73.7% increase in total resistance. And the third thing is that I have calculated the biological drift times. Now, from the proposed Vadhvan port's location, only 15 kilometers away is the Tarapur Atomic Power Station, and it has its cooling water along the coast, cooling water intake infrastructure along the coast. Now, what I've calculated is that with the basic drift speed of the water, the dislodged debris will actually be alive and can severely impact the already existing infrastructure. And I have calculated it to be 10.4 hours. It can actually reach these structures and can the living organisms can kind of attach and degrade the cooling water system. Next is that the true cost of inaction can be there is if biofouling is not properly accounted for, it can actually result in a huge fuel penalty, which, if we translate into economic terms, will be a 4.16 lakh rupee loss per hour per vessel. And this directly cuts into the carrier profitability and the aggregate port through output. And next is I have from the my matrix I have tried to quantify some of the terms. Now, first is possible regulatory fines. Now, if the uncaptured, if the sediments are not properly captured, it can actually be around 288 kilograms of active copper biocides in the water, which can be around a 50 crore exposure. Now, these numbers are not super accurate. These are based on previous fines and stuff, but it's a huge liability. Second can be the power station that I talked about. Now, per incident, the cost can be around 53 crores. Now, these numbers are very rough. These are not real life numbers. The port is not operational as of now, but it can be a huge economic drain. And third is that the fouled hulls can require mandatory quarantine, and this can demerge penalties and backlogs can cost around 50 crores per year. Now, this is basically a framework that I've developed. Now, these can also be quantified in economic terms, but because there are multiple different ways of anti-fouling, um, prop, ways. So I have not exactly quantified this, but I have built a framework like mandatory hull screening, biofouling management, sustainability compliance, and carbon abatement can roughly um, uh, make annual fleet fuel savings of about 350 crores. And 10% of this will directly go into the revenue ledger. Next is some policy directives that can help. First is standardized hull condition assessment, in which a formal port regulation can require all vessels with significant stationary periods to provide verifiable, non-invasive hull condition data prior to berthing. Second is zero discharge hull maintenance standards that will prevent the biofouling and the species to enter the water. And third can be a biofouling risk mitigation framework, which can take the graphic data and to inform predictive maintenance schedules. And with that, I end my presentation. Thank you.